Hello friends, welcome to Misostudy, and I hope the heading of this PPT itself telling what exactly we are going to discuss in this particular video. Just before this video, few days back, we uploaded a video about this electromagnetic induction JEE main pattern exercise, and at that point of time I promised you that in future we will keep on coming with these type of question sets. So just to fulfill that promise, it is the next set of questions, next set of questions, next set of questions. So this way things will definitely keep on coming in front of your eyes. Our intention in Misostudy is simple. We don't want to discuss few questions. No, not at all. Our approach is in totality to equip you people with the conceptual clarity in such a way that you should able to attempt these questions by yourself. Fine. So these are representative questions. As in the previous slides of these question collections, I explained you the approach. Same I will do again over here. Fine. So let's start this discussion in the same manner. Again, we will try to learn, we will try to understand the concepts and the approach. Okay. So herewith I am starting this discussion because it is in the continuation. So this these questions are coming in that particular sequence. So that's why I gave number 6. Otherwise, it is of no way important for your understanding. Now, what exactly the phenomena is? First, I will explain you the situation. Two conducting rings P and Q, name is given and diagram is here, of radius is small r and this 2r. So if it is small r and it is 2r, fine, let's make it like this, r and this is 2r, fine. Now, moving uniformly in opposite directions means if this small one is going towards the left side, then this bigger one is coming towards me in the right side. Okay. And center of mass velocities is 2v and v. It means a smaller one is moving with the double velocity comparing to this bigger one. Okay. And that too, both these rings are placed on a conducting surface. Conducting surface means on which they are moving, the surface is, let's say for example, made up of metal like iron, copper, something like that. Fine. And there is a uniform field of magnitude B, very clearly mentioned. And as per the symbolic representation, this magnetic field is perpendicular to this green board but outside towards the camera. Fine. So perpendicular to this green board but towards the camera. Okay. So some amount of magnetic flux passing through this and passing through this, and when they are moving in opposite direction, so flux is also changing. Okay. There is a uniform field of magnitude B perpendicular to the plane of the rings. The potential difference between the highest points of the two rings is how much? Okay. What I will do, I will write down one line and I will show you a diagram. After that much, you are definitely going to be in a comfort zone of solving this problem. So what is that line? First I want to mention that. Fine. That line is motional, O-N-A-L, motional EMF. Fine, motional EMF is equal to BLB. I hope you will able to recall the concept that I explained you during the discussion of theoretical videos. There even I use the example of an aeroplane also. Fine. So B is the magnetic flux, V is the velocity and L is the length of that you can say axial, or you can say wings expansion of the plane. So this is the basic concept we are going to utilize over here. Number 1, fine. Number 2, I promised you I will draw a diagram, because from this it is not clear what is the meaning of highest point. Highest point means this point and this point. It means if we are considering highest point, then we have to also take care of the lowest point. Fine. So that's why I said I will draw a diagram. So let me use this yellow color is smaller this circle, and this point is A and this point is B. Remaining diagram is same, 2, V, R, everything is same. And then let me allow to use a blue color chalk. This one is bigger ring, fine, and this point, let's say, is C and this point is D. So now I hope upper points, topmost points are clear. Now no need to take the look of this diagram, because I recreated the diagram over here. Fine. So now I am writing a equation. Please try to be the part of this equation. What is that equation? I am writing A, motional EMF at point A, minus B, motional EMF at point B, is equal to B. Why B? Because magnetic field is B. This is B. So B into what is the velocity of this particular segment? That is 2V. And what is this gapping? It is 2R. So 2V into 2R. Compare your result with this result. Fine. What you will get? EA minus EV is equal to 2 to the 4 BVR. Fine. So let me allow to write down it with the different color chalk. E, that is induced EMF, minus B is equal to 4 BVR. Fine. Now same operation, same procedure we will apply at this point. That is, EC minus ED is equal to B, velocity of this is V, and this is this entire gapping, this diameter is 2 plus 2, 4R. Why 2 plus 2? Because it is 2R. Okay. So let's write down. I think I should write down over here itself. Fine. So this time I think I should use this blue chalk, because I am writing this for blue color ring. That is C minus D is equal to B V into 4R. If anyone has any confusion about 4R, 2R, so for all those students, here is your solution of this confusion. 2R. Fine. Now what it will give you? It will give you 4BV into R. Fine. So let's say this is equation number 1. And this is equation number 2. What we have to find out as per the demand of the question? Potential difference between the highest points. So what is the highest point? A. What is the highest point? C. So what I should say? I should say EA minus EC, because B and D are lowest point, and in the question they not asked anything about the lowest points. So finally what we have to do, I think I should use this space which is available to me, that is E, highest point is A, minus C, because highest point is C, is equal to 4BVR minus 4VBR. So, it will give you 8VBR. I think I should finally write down this expression over here. Okay. So, that way EA minus EC is equal to 8BVR. Option is in front of your eyes. C is the correct option. Everything I explained, approach, concept, basic approach, every aspect of this question has been explained to you. Okay. So, you should try to pick up questions, solve question in this fashion. Why? In examination hall, a small amount of confusion will create lot of difficulty. So, during the practice before the exams, like 1 month, 2 months, 3 months before the exams, if you follow this approach, obviously you are going to get very good marks. Less number of confusions in examination hall, more numbers you are going to score. Fine. So, all these experiments you can do with these problems in your during your preparation time. So, that is why I am telling you what should be the approach in totality of these questions. So, now let us move ahead for this next question. Okay. I do not want to come between your question and you. So, that is why I am standing slightly away from your question. Now, just try to understand the problem. A rod of length L, this rod, rotates in the form of a conical pendulum. Conical pendulum means like this way, okay, like this way, circularly. Rotates in the form of a conical pendulum with an angular velocity omega about its axis as shown in the figure. Actually, this tilted arrow this is showing you how exactly the rod is rotating. This is the rod, it is fixed like this and then it is rotating in this fashion. Fine. The rod makes an angle theta with the axis. Which angle? This is straight rod. This is angle and then it is rotating. Fine. Theta with the axis, the magnitude of motional EMF, movement motional EMF terms comes in the problem. You must think about BLB. Okay, you have to change that shape, that is not a problem, but you should learn, you should think in this direction. Motional EMF developed across the two ends of the rod. Now, this concept is based upon a simple derivation which is the which derivation is the part of your NCERT books. Fine, and this is very important derivation and the final result like half B L omega square type of result. So, we designed this question based upon that particular concept. Okay. Right now, no need to take the look of any of the options. First, we will try to solve the problem using the concept, only then we will move for the picking of the correct options. This is the best approach of MCQ type of questions. Fine. As I hope the problem is clear to all of you, so let me allow to use this space of the board for your explanation. Now, as I mentioned, motional EMF in case of rotation, motional EMF in case of rotation is given by is equal to half B omega L square, where B is the magnetic field, omega is the angular frequency, angular velocity, fine, and L is the length of the rod. You can say how directly we can use this result. As I mentioned, this result is based upon a derivation. So that's why it's not like that we are directly using over here this result. Problem is, what we will say about this L? Because if the rotation, if the vibration of the rod is like this, no problem, directly mention L, but the situation is not like this. Situation is like this. So ultimately this is the standard result. Fine. Over here, what is the actual value of L? So first I would like to show you with the help of a diagram at this place something, and only then I will tell you how you can find the value of L. Okay. So here, if I would like to explain you this situation, for the time being I am going to hide this diagram. Basically, the rod is rotating onto this type of path. Okay. And then this angle is theta, and this yellow color distance, this yellow color distance is L. So actually what the length, useful for us is not L, but it is L sin theta basically required. So in this standard result, what I should use? I should use it like, I hope now it's more clear to you, is equal to half B omega and L sin theta whole square. Now answer is in front of your eyes, that is equal to half B omega L square sin square theta. Fine. So this problem is as such not difficult one, only required is you should visualize the situation. That's why 3-4 times I explained the way it is rotating. And sometimes with these type of questions, the tendency of the students is like this: oh my God, such a big question, such complicated options, let's move away from this. Don't do like that. At least develop patience in your approach. Read the problem, think, use your basic understanding to solve it. As such, you may say nothing is difficult in this particular problem, but just because of your escapist tendency, at some point of time you may find yourself in a difficult situation. So please avoid this type of approach. Fine. Read the question, think at least once or twice. If still you are unable to solve it, please don't waste a lot of time on a single question. It is also a $1 million advice for competitive exams. Okay. So after this, let's move ahead for the next problem, and here in front of your eyes it is next problem. I hope these small x cuts are visible to all of you. It is nothing but simply showing that magnetic field is perpendicular to this green board inside. Fine. In earlier problem, earlier problem, that was I think 6th question, it was outward, here it is inward. Fine. When a J-shaped conducting rod means, I am sure you must have noticed this type of bamboo stick with old people. Fine. They used to hold it like this and then they use it to support their motion. Fine. So this type of stick is type of rod, J-shaped rod. Over here this turn is given. when a J-shaped conducting rod is rotating in its own plane. In its own plane means it's like this way. It is rotating like this way. Fine, in its own plane. In its own plane with constant angular velocity omega. About one of its ends at P. Fine. In a uniform magnetic field B, directly normally into the plane of the paper. Then magnitude of EMF induced across it will be how much? Please wait. Don't rush for the solutions. Fine, what you should do? Don't you think the approach is up to some extent similar to the previous problem? Yes. Don't you think the approach is demanding motional EMF with rotation concept? Just few minutes back I mentioned this induced EMF is equal to half B omega L square. You may say yes, correct. Now problem is this L is the gapping between two ends of this J-shaped rod. How much it is like that? It is like that, let's say this is the J-shaped rod. So this much gapping is capital L. I hope now clear. And then this much gapping is small l. Problem is simple. You cut out this portion and answer is half B omega small l square. But here this is something, this twisted part is creating a problem. Basic approach is same. Okay. So let me allow to mention this result. Motional EMF in case of rotation, this line I mentioned already. So directly I am writing half B omega, let's say L prime square. Don't get confused L with this L. Okay, this is a general standard result. Now we have to mold this result as per our requirement. Okay. So here L prime square. Now consider the situation, that is half B omega half B omega. Now what about this L prime square? How we will find out this L prime square? Rather than going into details of the basics of you can say trigonometrical aspect or calculation using some sort of algebra, what I will write down over here, that L prime is equal to under root L square plus L square. So L prime square L square plus L square. Fine. Now you may say this C is the correct option. Let me allow to put the values over here. That is L square plus L square. So you may say these questions by look they are quite complicated, but moment you start solving them, they are very simple. Electromagnetic induction, EMI, the chapter from which we pick these questions, is utmost important chapter. But what I am trying to prove, even these type of complicated questions from this chapter, the solutions, approach, concept, formulae, very simple. Fine. So try to develop some sort of liking. I would like to mention one important aspect. There are two chapters in class 12th. One is electromagnetic induction, another is AC circuit. Both are based upon each other, or you can say AC circuits is totally based upon EMI. Now if you just revise, just make yourself comfortable in these two chapters, whether it is JEE Advanced, JEE Mains, NET exam or any other entrance exam, minimum 2 to 3 questions. Minimum 2 to 3 questions, and this is something I am saying The recording is available. Check yourself and then come back to me if my statement is wrong. Very simple concept, and with surety you can say yes. These number of questions obviously I am going to get. Fine. So let's move ahead, but with this suggestion, please make yourself comfortable with these two chapters. Try to recall your board exams. Lot of possibility of long questions, 4 marks, 3 marks or 5 mark questions asked from this chapter. Fine. Inductor, resistors, capacitors, their combination in AC circuits. So very important chapter. Now here it comes question number 9. Beautiful circuit, very difficult question as per look, but it is just a makeup of sort for a fancy dress competition, nothing else. What we will try to understand this problem. So now I am not in front of your question is in front of you only. In the circuit shown, this one, A is joined to B. Fine. A is joined to B. Right now it is not joined, but for a long means for a long time. Fine. Then A is joined to C. First take a wire, a connecting wire, put it on B. So now there is a connection between A and B. Leave it for some time. After that, pick that wire, put it on C. This is the way of operating these circuits. Initially, after that, fine, A joined to C one by one. Okay. The total heat produced in R. Don't you think the person who created this question, I not created, fine, jumped slightly in this particular approach. Why? Problem is, moment you connect it like this is inductor mentioned to L. So obviously some sort of energy flow will take place, and because of that energy flow, heating will come out, heating will be produced. So very first, very important thing, you should try to understand what exactly they want to say. Their solution of this problem and their approach, I mean approach of the person who designed this question, is very simple. Fine. This diagram saves at least 5-6 lines from this question. That's why they created this diagram. Now let me show you the magic. The answer of this big problem is just in one line. How? I think I should draw a straight line. Total heat produced equal to then rather than writing at this place, I am writing below. Total heat produced is equal to energy stored in L. In L means in inductor. So ultimately the amount of energy stored in inductor is nothing but it is going to be appear in the form of heat across resistors. Fine. So what is the energy stored in the inductor? Half L I naught square. Is this a new formula? No, not at all. Basic result. Even this result is used to find the dimensional formula of L. Fine, class 11th even. So half Li square is equal to, now actually they want the value of I naught from here. Fine. So what I am saying, but I naught is equal to E upon 2R. Fine. this E upon this 2R. Okay, because it is mentioned over there in this format, so let's make it like this, no problem. Now half L I naught square, replace this value of E upon 2R. Okay, so let's replace the value half L square upon 2 to the 4R square. Fine. So correct answer itself is saying I am the correct answer. LE square upon 8RE square. LE square upon 4 to the 8R square. Just one formula. What I said, in one line you will get the answer. These questions are really very beautiful from EMI. Okay, try to develop a habit of liking for these questions. Again and again I am telling. And one more thing you can do. Don't consider it as a challenge, but simple suggestion. After solving these problems, lay your hands for last 38 years IT, JEE, advanced mains exam paper collection. In the market it is available. We are also providing. And just open that EMI chapter and start solving the problems. The more number of problems you will be able to solve, the more you are going to get confidence in your approach. Fine. Then comes question number 10. Again a big diagram and of whatnot. So first try to understand. Diagram shows uniform magnetic field. Now here this X, this X, this X, I am sure it's visible to. Fine. So it's showing magnetic field is perpendicular to this green board inside. This X, this X, this X, this X, this X. This way things are visible to you. This small v is visible. Let me make it more clear to you. 0.1 m. It is X, it is X, this is D, this is 3 ohm, C, V, and so on. Fine. So the magnetic induction is 0.1 Tesla, B value, and resistance of connector R is 1 ohm. Fine. The sides AB and CD, this is A, this is B, this is C, this is D. The sides AB and CD have resistance 2 ohm. I think I should make it slightly dark. 2 ohm. Actually it is just the arrangement of these technical issues, otherwise things are quite simple. Respectively, find the current in the connector during its motion with constant velocity v 1 meter per second. So now what exactly is given? You can say it is moving, a rod is moving in this direction. So obviously flux is changing. So motional EMF will come into picture. And what is the formula for motional EMF? That is, I think yes, I should write it down over here, is equal to BVL. Fine. So basically we will try to use this relation. I is equal to BVL upon R net. Many of you will say, how can I write down the formula? Okay, don't worry, I'm not writing this formula. But at least I have the right to write down like this. Nobody can stop me. But, sorry, Ohm's law. So I naught is equal to BVL upon R net. What's the problem? You can't stop me now. So now VBL upon R net. What is the value of R net? 3 into 2 upon 3 plus 2 plus 1. Why? Because these two are in parallel combination and connecting one is in series combination. So R net is equal to 3 into 2 upon 3 plus 2 plus 1. How much it will give you? 6 upon 5. That will give you 6 upon 5 plus 1. So it will give you 11 upon 5. Okay, 11 upon 5. Now put other values as they are given. Fine, in this particular problem 0.1 Tesla and 1 meter per second and so on. So after putting all those values, I will come as 1 upon 2 by 20 ampere. Now at least after watching these many problems, let me allow to use this space. Repeatedly I am using BVL or half B omega L square but is equal to IR. Only 2.5 result, that's it, only 2.5. So you can say just by using one or two simple expressions, if you can calculate so properly, so many marks, it's very better approach. Fine. So once again students, I would like to say that we should stop over here. Fine. At some appropriate time in future, very soon I'll come back with more number of problems, maybe like 11, 12, 13 and so on and so forth. So till then, keep revising, keep working on your basics of this chapter with AC circuits. Till then, take care also. Have a nice time.